Okay, this is my Unit 3 Unit 3 FRQ test corrections, and I got a 8 out of 12 on it. Okay, so for number 1, part A, I got it right, 120 seconds per 1 revolution. So I got full points on that one, so that's a +1. I think that's a 1-point question. Let's see. So for part, so the first part of part A. The second part, I got one of the available points because instead of radius, I found the diameter of the Ferris wheel, and so my thing was 2 pi r over t, but it should have just been pi r over t. So my answer was 3.142, but it should have been 1.6. So I found the radius wrong on that question. Let's see. Let's see part B. I got +2 -1 on this question because I labeled I labeled 2 forces, but I labeled tension instead of the centripetal, or instead of the normal force. Since the object that you're looking at is in the compartment and you're not looking at the compartment as a whole. So it's moving because it's attached to the kind of like bench in the compartment. So I did force tension, force gravity, but it should have been force, normal force and force of gravity, because the normal force is an object in the compartment that is moving. So the actual thing that's moving the object in it, the book, is normal force, not tension. This is for part 1. So part 2. Let's see, this one. Okay, this one was just labeling up or down, so I got this one right. Let's see the question. Lowest point section, vertical force. So yeah, I put up, and that was correct. And then without deriving any equations, explain your reasoning. So my reasoning was in terms of tension and not normal force, but if you use the same logic, then it still works because the tension, or the correct term, the normal force would need to be stronger than the force of gravity in order for the book to be moving, and if they're the same magnitude, the book would remain at the bottom. So that's why the tension, or the correct answer, the normal force, has to be stronger. So I got a +1 on that one as well. Alright, part C. This one I got -2 points. I got one of them. I correctly used Newton's second law with the diagram. Instead of normal force, I used tension equals mv² over r. So yeah. So even though I didn't use the right variable, I correctly identified which one that would have been correct, and I set it equal to the right thing, Newton's second law. But I didn't get the correct centripetal acceleration on this. So it should have been, so if I would have done this correct, let's see, so the total force, So it would have been mv squared over r. And you just plug the stuff in. So it would be mb vb squared r. And that would be equal to the normal force. The normal force, oops, can't see that. That would be equal to the normal force minus the force of gravity. So basically, what force is left after those two forces cancel each other out. And then for part D, at the lowest point of the circular path is the force that the bench exerts on the book greater than, less than, or equal to the weight of the book. And I correctly identified that it would be greater than. And even though my work was again in terms of tension from getting that previous part B question wrong, I correctly identified why the tension would have to be greater, because at the lowest point the ride is pulling you up, and the force pulling you up is the tension, means that the normal force will also be increasing, and since every action has an equal and opposite reaction, that means it would be greater. If you isolate, let's see, force, yeah, so just equal and opposite reaction, there will be a larger force down, and that would increase the weight of the book. So the compartment is pressing against the book on here, and so if it also has if it also has gravity and if the bench has gravity and the book pressing down on it as it's trying to go up, then that means the force would be greater than if it was at rest and not moving.